are used to represent relationship between data and necessary linear algebraic operation on matrices. So approximately representing matrices by decompositions. In two decompositions are there, SVD and BCA. Then we need to study statistics, descriptive statistics, and statistical inferences. Then statistical modeling, probability distribution, fitting a model, and hypothesis testing. This is the syllabus. What are matrices? Matrices are fundamental in data science for representing data and relationship. They efficiently store and manipulate numerical data, forming the basis for linear algebra operations used in machine learning and data analysis. Matrices can represent tabular data, relationship in graphs, and are crucial for various data transformation and computations. Here is how matrices are used in data science. This is the application of matrix in data science. You had already studied matrices in your school classes. So, tabular data can be represented using matrices. So, it can be represented as a graph also. So, we are having some nodes and we will denote graph using some relationship. The image is represented as a matrix. Then user item matrix. This recommendation is represented using a matrix. All these applications are represented using matrices. Tabular data. That is this one. Tabular data. We are having age and income of customers. Each row is a customer and each column is a feature like age or income. So each row is a customer. 4 customers are there and each column is a age or income. Then graph. It shows the connection between nodes. One means 2 nodes are connected. Then we are having grayscale image. So means each value represents the pixel's brightness. The smallest unit in an image is pixel and it shows the brightness of the image. Then recommendation system, it shows user and image. It shows how users rated or interacted with the different items. It is used in recommendation systems. So another example. So these are the examples. Customer data. So here for 3 customers and these columns represents the features, that is age, income, location. Then again image is there. The pixels represents the brightness of the image. Social network is represented. So if there is a relationship between person A and C, then it will be represented as 1. Otherwise, it is represented as 0. Customer data matrix. Each row is a customer. Column represent features like age, income, and location code. Then grayscale image matrix. Each cell is a pixel and value represents the brightness. 0 means black, 255 means white. If it is 253, it will be approximately a white color. Social network, that is adjacency matrix. Each row and column is a person. One shows a connection between 2 people. Example, person A is connected to person B. Look at this example. Person A is related to B. That is why it is 1. Otherwise, it is 0. There is no relationship between person A and person C. So, it is 0. Another examples. image M by N matrix for a grayscale image, that is pixel intensities. Uh, for This is for grayscale image, and for 3D, that is color image, it will be M by N into 3, because we are representing R, G, B colors. That is why here 3 appears. Then text. Text means it is document or matrix. Row means documents and column means unique words. Entries are word counts or frequencies. Then another data representation is user item rating. So user movie rating matrix. Rows represent users and columns represent movies. Entries are user ratings. These are some examples for metrics. Sometimes application of metrics will be asked. Tabular data, that is feature sample metrics. Rows are the observation or samples. Columns are different features or variables. That is student grades or sensor readings. Matrices are used to represent and store data on machines. It is the natural approach for organizing data. Data is organized in the following manner. Rows represent samples, columns represents the values of the variable. It is also possible to use rows for variables and columns for samples. However, we will stick to rows as samples. Always sample will be represented as rows. In columns, features will be represented. Are all attributes in the data matrix relevant or important? No, they are not related. Some cases we can delete the rows. We can choose some rows. If there is some relationship between these attributes, we will select it so that we can reduce the size of the data matrix. So linear algebra, we need to understand the vectors, explore the matrices, delving into eigenvalue and eigenvectors, utilizing singular value decomposition, applying principal component analysis. So what is data? We had already studied data in the first module. Data refers to raw facts, measurements, or observation that can be collected and processed. These can be numbers, text, images, sounds, or any other observable elements that carry information. So it can be speech. Speech means it recorded audio clip of someone says, "Hello, class of GNST 305. Then image, a photography taken using a mobile phone. Text, a sentence typed in a chat application. Sensor data, that is a temperature sensor reporting temperature in degrees Celsius every 5 seconds. Transaction, an online payment record containing amount, date and seller. These are examples of data. Understanding the data. Data sets that store the units of information and their properties can be imagined as collection of data consisting of the following. So we already studied these things. Example, it is the instance of a unit of observation for which properties have been recorded. An example is also referred to as instance or case or record. Then next is features. A feature is a recorded property or a characteristic of examples. It is also referred to as attribute or variable or feature. Some examples. We had already studied this. This is just a revision for you. Cancer detection, unit of observation patients. Examples are members of sample of cancer patient. Following are the attributes of patient, that is gender, age, blood pressure. So these are the features. I had already studied this. Rows represents the examples. So types of data, we also already studied this. Numerical data, it is divided into discrete data and continuous data. Numerical data is otherwise known as quantitative data. And another type of data is categorical data, that is qualitative data. It is divided into nominal data and ordinal data. The next type of data is text data, that is documents or reviews. Then multimodal data, that is image or image plus text. More than one modality of data will be there. Numerical data. Numerical data consists of real or integer values that represent measurable quantities. So numerical data is divided into two, discrete data and continuous data. Discrete data, it consists of distinct separate values. It arises from counting things. Whatever we can count, countable objects are known as discrete data. And infinite number of values within a given interval. This is important. So within this interval, some values are counted. This is infinite. This is finite. And also this is countable. This is uncountable. Uncontinuous data means uncountable. Countable means number of students, it is countable. Number of books, it is countable. Number of goals scored in a match, countable. Temperature, we cannot count it. It is infinite number of values will be there. Speed, infinite numbers. Height, again infinite number of values will be there. So these are the different types of data. Discrete data and continuous data. The next is categorical data. Categorical data means it consists of labels or names used to identify the categories or classifications. Types of categorical data: nominal data and ordinal data. That is, categories without any natural order are known as nominal data. That is, they are just labels: apple, banana, grape, male, female. No ranking is there. Then ordinal data means there will be some meaningful order. If there is order, then it is ordinal data. If there is no order, nominal data, no order, n. Nominal, no order. You can remember like that, n. So examples of ordinal data are excellent, good, poor. This Amazon product rating. Order is meaningful, but gaps between levels are not uniform. Numerical data, we had already studied this. Discrete, it is countable. Continuous data means it can take infinite decimal values: height, weight, time, temperature, price, humidity, etc. Categorical data, examples: nominal data, there is no order. Ordinal data means categories with order. These are some examples for nominal data and ordinal data. There is some order, then it is educational level, primary, secondary, graduate. So this order is very important. We cannot change the order. Consider these fruits. We can change the order: apple, mango, orange. Like that we can change the order. In ordinal data, we cannot change the order. Identify which is category and numerical value. Temperature, it is what type of data is it? Is it category or numerical? Yes or no? There is some order is there. True or false? Order is there. Is it? Price. Okay, tell me what are the different types of data? How will you convert categorical data into vectors? So in machine learning models, we need numerical input. Categorical data must be converted into vectors using encoding techniques. So different encoding techniques are there. This question is very important. How will you convert categorical data into vectors? So different encoding techniques are there: label encoding, one-hot encoding, and ordinal encoding. Label encoding means we will assign a unique number to each category. For apple, 0. Banana, 1. Grape, 2. Like that, we will assign a unique number. So it implied order that does not exist. That is bad for nominal data. That means there is no, if there is no order means it will be bad. One hot encoding means we will assign, create a binary vector for each category. For banana, we will assign 0, 1, 0. It avoids any assumption or order. So here order is important. Here order, it avoids any assumption of order. Then ordinal data means it is used for ordered category. Ordinal, ordered. Like that you can remember. Ordinal is meant for ordered. Poor, 0. Good, 1. Excellent, 2. What is label encoding? Label encoding means it assigns an integer to each category. For apple, 1. Banana, 2. Cherry, 3. Mango, 4. Orange, 5. One hot encoding. It converts categories into binary vectors where only one vector is hot. 1 to represent the presence of the category and the rest are cold. That is for fruit, apple. First one is, so apple represent this vector 1, 0, 0, 0, 0. Banana means the second one is 1. Cherry means third one will be 1. Mango means fourth one will be 1. Orange means fifth one will be 1. So we cannot add any more fruits to this because we are actually using 5-bit vector. For color, we can again use 5-bit. So 5 colors will be 4 colors. 4-bit is used. So 4 colors can be used for this encoding. Ordinal encoding is used when categories have natural order or ranking, but we will still want to encode them naturally. Educational levels, high school 1, bachelor's 2, master's 3, PhD 4. In this case, PhD is greater than master's, greater than bachelor's, greater than high school. So order matters. This is not suitable for things like fruits or countries because there is no natural order. Ordinal data is for ordered categories. Then about text data. Text data is sequence of characters or words. It is usually unstructured and requires pre-processing to convert them into numerical form. In computer machine learning algorithms, numerical forms will be accepted. We cannot input text data into the algorithm. So an example is a product review that says this phone is excellent. So in machine learning works with numbers only, not raw test cannot be applied to the model. So text data is unstructured. Words must be converted into numerical values. Our goal is to represent text as vectors or matrices that capture the meaning or frequency. So we are having corpus. Corpus means we need to convert the unstructured text data into structured form. Corpus means the large structured text set of text used for linguistic or statistical analysis. For example, AI is powerful, AI is everywhere. This is the sentence. We will break this sentence into smaller pieces. That is, each piece is known as token. First one, if there is a space, we can split. AI is a token, is another token. If there is a space, we can split it. Powerful. Then and, AI, is, everyone. These are the tokens. So vocabulary, we can construct unique tokens from this. Here, AI, is are repeating. So we can avoid those tokens and we can construct a vocabulary from these tokens. Then next is bag of words representation in text data. So if there is a sentence AI is powerful and AI is everywhere, vocabulary is AI is powerful, we can delete the common term. That is common. So one is there. AI is common. So one AI is eliminated. So bag of words means frequency occurred in this. It is count. Look at this. Okay. First one is AI. First one is AI term. So how many AIs are there? 1, 1, 2. So frequency is 2. Is 1, 2, 2. Then next is powerful. Only one term. So 1. And one term 1. Everywhere 1. So AI appears 2 times. Is appears 2 times. Powerful and everywhere appears once. So this vector ignores word order, but it reflects the term frequency. So sentence becomes matrix. Like that we can represent. If AI, then it will be 1. AI and 0. AI everyone. AI is 0. Like that. Is 1. Powerful is 1. And is 1. AI is 1. Is 1. Everywhere is 1. So this is the sentence. So data, that's about the data. The next topic is linear algebra. Data in computer systems is structurally numerical. So linear algebra is a compact and efficient framework to represent and analyze data. So we have two key representation, vectors and matrices. Vectors means it is one-dimensional array representation and matrix is two-dimensional array representation. In physics and mathematics, what is vector? Vector means it has magnitude and direction. But in mathematics, vector is a ordered list of numbers, one dimensional array, that is vector. Example in physics, a force of 10 Newton acting to right. So we will be pointing an arrow to left like this. This is force. And it is proportional to 10. Here, it represents position or direction in space. We also represent an arrow like this, and it can be plotted from the origin 3 to 4. 3, 4. Like that we can plot one vector. Look at this. 3, 4 describes a point 3 units right. A point 3 units right. And 4 units up. So this is the vector. And magnitude is find using the 3 square plus 4 square. Then take the root, that is 5. Root of 3 square plus 4 square, that is 5. Norm and magnitude of vectors. Sometimes they can ask this question, what is norm? Norm is like this. It is denoted like this. It is root of x square plus x1 square plus x2 square plus etc. plus xn the whole square. So norm of 3, 4 is you have to take the square root of squares of sum of each elements present in this vector. So norm of x is 5. So you can try this. C equal to 1 minus 2, 2. So you have to take the square of all the terms, then take the square root. Okay, try these examples. Vector is a list of values arranged in single row or column. So, feature vector of a student is represented like this: height, weight, age. This is the height of student, weight of student, and age of student. So, there are three quantities. So, it is a representation of three-dimensional real space. Okay, three features are there. We cannot represent it using two dimensions. Then what is dot product? Dot product represents the similarity between vectors. A dot B is represented as sigma I equal to 1 to n ai bi. So it is also represented as norm of A into norm of B into cos theta. If theta is 90 degree, then we can say that vectors are orthogonal. That is, it will be like this, orthogonal vectors. The dot product measures how much two vectors overlap in magnitude and direction. So dot product is another question. Two vectors A and B, the dot product is defined as A dot B equal to norm of A into norm of B into cos theta, where norm of A and norm of B are magnitudes or length of the vectors. Theta is the angle between them. If theta is equal to 0 means cos theta is equal to 0. Therefore, A dot B equal to 0. What dot product measures? It measures the similarity of the vectors. If A dot B is 0, A dot B greater than 0, then vectors point in the similar direction. This is the significance of dot product. So A dot B equal to 0 means vectors are perpendicular and also it represents independent or uncorrelated values. A dot B is less than 0 means the vectors points in opposite directions and there is a negative correlation between these two vectors. If A dot B is greater than 0 means there is a positive correlation between these two vectors. So this measures how much two data vectors are alike. So exercise. Check if the vectors A equal to 0, 1, B equal to 1, 0 are orthogonal using dot product. If this A dot B equal to 0, then we can say that these vectors are orthogonal. Vector spaces in data. Each point in n features can be viewed as a vector in Rn. A data set with n sample becomes a collection of such vectors. D equal to x1, x2, xm is a subset of Rn. Here, xi represent x1i, x2i, etc. xni represents the ith sample. This view allows us to apply algebraic and geometric operation in n-dimensional space. That is vector space. A space comprised of vectors collectively with the associative and commutative laws of vectors and also associative and distributive process of multiplication of vectors by scalars is called vector spaces. So axioms in vector spaces includes closed under addition, closed under scalar multiplication, commutative property of addition, associative property of addition, existence of additive identity, existence of additive inverse. Existence of multiplicative identity, associative of scalar multiplication. Distribution of elements to scalars, distribution of scalars to elements are the axioms in vector spaces. This short question is important. What is vector space? That means it is a collection of vectors which satisfies these axioms. So how will you represent a data? Understanding 1D data. 1D data means it is a point that is one dimension. Single feature is there, temperature. It is 30, 10, 32, 28. It is an element of R1. 2D vector means it is R square. Two features are there. That is, there will be two elements present in this vector. That is element of R square. Two features, so R square. If there is n feature, then it will be Rn. So 3D means there will be three features. Height, weight, age. This is an element of R3. ND example means n features will be there. x1, x2, etc. xn. It will be an element of Rn. It is used in ML. 2D feature space, height, weight. Two features are there. So it is R square. Each point is a 2D data vector in R square. So what is cosine similarity? Cosine similarity measures the angle between vectors, that is A dot B divided by norm of A into norm of B. Ranges means it is 1 means it is in same direction, that is similar. It is 0 means it is orthogonal, that means there is no similarity. It is -1 means opposite direction. It ignores magnitude, focus on directional similarities. It is widely used in high dimensional data and sparse. So cosine similarity is an important question. Numerical example. So A equal to 1 0, B equal to 0 1. Dot product of A dot B means this 1 into this 0 plus this 0 into 1. 0 into 1, that is 0. So norm of A means this is A. A is 1 0. So you have to square all the terms, then add it. Then take the square root. That is magnitude. Norm, that is 1. So you similarly take B. So cosine is A dot B, that is 0 divided by norm of A into norm of B. It is 1 into 1, that is 0. Dot product is 0. Cosine is 0 means vectors are orthogonal. There is no similarity. So another question. Do this question. Which of these vectors are pointing in the same direction? So conforming it using dot product and cosine similarity. So first step is you can check the dot product. A dot B equal to positive means it is high similarity. A dot C is negative means it is in opposite similarity. A dot D is positive means it is slightly aligned and it is weak similar. Here it is positive, here it is also positive, but high positive means high similar, less positive means weak similar. Cosine similarity also, you can compare these two values. Here this is 1 1, so that is a perfect match. This is -0, that means it is in opposite direction. Negative means it is in opposite direction, so there is no relationship. It is greater than 0, so some alignment is there, but it is not 1, so it is not perfect. So you can compare these things and you can get the output. Application. These are some applications for this similarity and dot product. These algorithms are ML algorithms you will study in your higher classes. Another example. You can work it out. Orthogonality in machine learning. Two vectors are orthogonal means if their dot product is 0, this means that they are completely unrelated or independent. Orthogonal means there is no overlap in information. In PCA, principal components are orthogonal to ensure no redundancy. In text or data embedding, orthogonal vectors imply unrelated topics or context. Application in data science, machine learning, image processing, recommendation systems, NLP. So matrix, this is scalar. This one is vector, one dimensional. Matrix, that is 2D. Then ND means it is tensor. This collection of matrices or vectors. Scalar means it is character, vector. Matrix means page or images. Tensor means books or videos or series. Matrix means there will be rows and columns. Each column is a feature. R is an element of M by N. Tabular data. So it is 3 features are there, 3 columns are there. How do we work with matrices? You already studied these things, basic operations in matrices, addition, subtraction, multiplication, then linear transform. That is stretching, rotating, flipping, etc. Reducing the columns in is known as dimensionality reduction. It focuses on most important features in your data set. So where we use matrices? In machine learning, linear regression, neural networks depends on machine matrix operations. In computer vision, in recommendation system, in data analysis, etc. These are the key concepts in matrices. Dimension means how many rows and columns. That is 3 into 2. Matrix means 3 rows and 2 columns. Elements means each number in a matrix is called element. We can locate it using rows and columns. Type of matrices, square matrix, same number of rows and columns will be there. Diagonal matrix means only the diagonals as values, rest are zeros. Identity matrix means a diagonal matrix with all ones on the diagonal. Why matrices are important? Because we can organize data in a clean, structured way. We can process large amount of information, apply powerful math operations. We can apply software tools easily. That's why we use matrices. Here the students' marks, they are having maths, physics, chemistry. So this is maths, this is physics, this is chemistry. Row is a student and column is a feature. Always like that. So relationship can be represented like this. In a social network, 4 people, 1, 2, 3, 4. 4 people and 1 represents if there is a relationship. This means there is a relationship. 0 means there is no relationship between those persons. That is here 1, 2, person 1 and 2 are related because it is represented as 1. Basic operation you already studied in school classes, matrix addition and subtraction, scalar multiplication, matrix multiplication, transpose of matrix, rows and columns are interchanged. Identity means only diagonal will be there, other elements are zeros. Inverse, determinant. Determinant of A is AD minus BC. When determinant is 0. If the column vectors are linearly dependent, they lie on the same line. So the parallelogram collapses into the line. Previously we are having a parallelogram. This parallelogram is collapsed to a line. This means they are independent. The area is becomes 0. So determinant is 0 means there is no area. Linear transformation. Vector can be transformed into A into V. It can stretch, rotate, compress or reflect. So 1, 1 can apply transformation like this. Matrix rotation can be applied. You can apply counterclockwise or clockwise direction. These are just operations. Trigonometric identities can be applied in rotation and rotation matrix will be like this. So these are different angles and the rotation matrix. These are some advanced topic. I am not going into the detail of these things. In exam point of view, they will not ask these questions for you. I will stop here and continue in the next class.